So if you want to go back and review any particular portion, you'll have that at your disposal in the next day or two. All right, Gary, so I'm going to hand this presentation ball over to you.
Great. Thanks, Lauren. Really appreciate it. And once again, I'd like to thank everyone for taking some time out of their day to come and learn a little bit more about SciFinder-n. Hopefully, you'll see that it has a lot to offer, a lot of new capabilities, and I'll get to many of those as I can. Since this is such a large call, I'm actually going to stop my video now for reasons of bandwidth, and I will start sharing my screen. Confirming, Lauren, that you can see my screen.
Yes, sir. Looks good.
Great. Okay. So this is what it'll look like once you log into SciFinder-n. This is the home page. For those of you who've used the SciFinder Classic version, you'll notice the ability to do substance reaction reference searching on the home page. A couple new things have been added. A lot of customers are asking, hey, can we go right to a supplier? I have a compound. I want to look at commercial availability. I want to look at pricing. And so without having to do searching, you can just launch right into that type of search. The all search is something that we put in for situations where you've got a search in a new topic area. You kind of want to make sure you've got a nice query defined. So I can go ahead and launch a query. And if I click the all search, it will give me the top couple of answers from each of these different fields if applicable. And then I can say, yeah, I'm good to go, or maybe I want to refine that down a little bit before I move any further with this query. You'll also new to the home page are the last 4 searches I ran. Just to let you know, I apologize for my throat a little bit here today. SciFinder-n will remember absolutely every search you've ever run. That is part and parcel for why we came out with this product here. SciFinder Classic, I've used it my whole career. Great product, still is a great product, but it is 25-year-old technology. So with the it's the exponentially growing amount of data, references, literature out there, we figured it was time. So we put in a new data model, a new search engine, built the whole thing from the ground up. And all this to say, now it will remember absolutely every search you've ever run. And if you want to access those, you can go up here to the history button. And I can access my searches in a couple of ways. First of all, I could scroll through them if I wanted to. 20 per page, and I've got 403 pages, so that will take me a while. So we've provided over here these filters on this page. So if I know the type of search I'm trying to find, whether it was a reaction search, an all search, or a retrosynthesis that I did, I can click on that and get to that pretty quickly. The second thing I can do is perhaps we say, hey, we were talking in that virtual group meeting that we had about a week ago about this retrosynthesis. Here, let me bring it up again. I can click on the date and then filter by the type of search it was. And I can say, yeah, this is the compound here. Let me open it up and we can look at it. So once again, just there will be a lot of emphasis on ways to save you time. So that's what all these filters over here are for. For many of you, and from what sounds like Lauren said, you're just getting access now. For those of you who have not had a chance to play around too much, as you do start playing around, if you have questions, we have a lot of different places you can go to get help. First of all, at the bottom of any search page will be help. If I click on that, it flies me out to a page where no matter what type of searching that I want to do, it will have information for me. For example, if I want to, I'm not so practiced, say, in using the ChemDraw tool, it can bring me to a page here where I can click on all the different menu items on the left-hand side and get a little explanation of what and how they can be used. There are also a number of videos down here. I'm a visual learner, so if I can see someone operating in a platform, I can usually pick it up pretty quickly. And then my position is a customer success specialist, so I support the sales staff. I do a lot of training. I help the product developers, specifically with the retrosynthesis tool. And since we're not doing so much traveling here in the COVID era, we did have time to sit down and put a bunch of webinars together. So on this help page, if I go on under About SciFinder-n, Um, I can go down here towards the SciFinder-n webinars, click on that. And if I want to learn a little bit more about substance searching or reaction searching or reference searching or the retrosynthesis tool, goes on and on. I can click on that and watch that. There's also a browser here for upcoming webinars. Coming up in the next couple of months will be some things that focus particularly on like agrochemistry or pharmaceuticals or inorganic chemistry. So if any of those are of interest to you, you know, keep an eye on this page and sign up for those webinars. They're 45 minutes and like 30 minutes for the webinar itself and 15 minutes for questions. All right, so that's the help. If it's something more mission critical, there's this thing called Contact Us down here at the bottom. Now, if I can deal with having an answer within a day, I can send an email and they'll get back to me within a day. But if I've got a big presentation tomorrow and I need to talk to someone, something's not working, and there's a new capability here I don't understand, I can call the help desk from 8 a.m. to 6 p.m. Eastern Daylight Time, Monday through Friday, and there will be a degreed scientist who will answer the phone. If they aren't the one to answer your question, they will quickly forward you on to someone who can. So once again, highlighting all the help that is out there. So let's now roll into the first area that I want to demonstrate, and that is reference searching. If you've used it before, you're used to entering your reference search query in that search bar, but there are, for some of these different search fields, advanced options. And so in this specific situation, let's say I want to pull back everything by Vanderbilt. And so it brings me back all the different publications, patents, clinical trials, biographies, what have you, published by Vanderbilt University or researchers at Vanderbilt University. So, and then I have all these different filters over here. In the specific situation, let's say I wanted to look up a specific professor there. And I like doing my presentations in person, but what's nice about being remote is that I don't have to do, or you don't have to watch me type a lot. I can paste things that I want to do. So I want to look up the publications of Professor Sulakowski. So I can go ahead and run that search. And I'd like to point out this feature because I think this is something that's pretty relevant. When you're searching a professor, you may have, I'm sorry, a researcher, you may have some information on them. It may just be the last name, maybe it's the last name and the first name, but you might not be certain all the different names they potentially could have published under. So I put in the information I know, and then it's going to pull back all the different possible publications that could be for a Gary Sulakowski. So this just means it's very comprehensive. I'm not going to miss out on anything. For example, if I just went just with Gary Sulakowski, I would have only gotten 12 of his. It looks like he usually uses his middle initial with a period. Editors every now and then make a mistake of not including a period. So just to make the point that I'm going to be able to pull back everything by Professor Sulakowski. And the reason I got into this field is I wanted to show you a capability called citation map. But before I do that, something new you will notice if you've only used the SciFinder Classic is rather than giving me the results newest to oldest, it's doing something called relevance. And I'll get back to that in a minute. But have no fear if you like newest to oldest, you know, that capability is still there. So yeah, like I said, not to worry. And in this specific situation, I'm gonna sort by time cited. So most cited to least cited, so I can show the citation map capability. And let's say I pick this article right here. This is of some interest to me, so I want to dig into this a little bit further. And in order to do that, I'm going to use citation map. So this is going to pull back all the references cited by Professor Sulakowski in this paper, and those are in this left-hand bar, colored purple. And they're going to be sorted by the most cited to the least cited references he used for his paper. So this alone is a good way to kind of look for seminal publications. Maybe this is the first time you may be looking at this field, and maybe you want to learn a little bit more about it. So, looking for those papers that are highly cited is a good way to go about that. But not only do we have that, we also have references citing this document. So this is kind of forward looking, right? Because this is published back in 2013. If this is, like I said, an interesting topic to me, I might want to follow this forward a bit and see what's been published since then. So for these articles that have cited this article here, they also have information if they've been cited a lot. So once again, kind of looking at those papers that may have some importance in this field because they've been cited by a lot of other researchers. And as I scan down, there is a color coding that kind of lets you know how many times it's been cited in a quick glance from highly to not as highly cited. The last thing I want to show you on this page, well, I should also point out there are some filters over here to help you if you want to refine down some of these documents by either an author or a concept. But let's just say I've decided that this is a very important article to me, and you know what, I might appreciate it if anytime this article gets cited, I could get a notification about that, because I would kind of like to see the researchers who are citing this paper, because it's probably of relevance to me if they are. And so if I come to this page, I clicked on the title on the last page, that brought me to this page. Now there's this little alert bell here. If I click on that, I can create a citing alert. So I can give it a name, I can give it a tag, I can color code the tags, as you can see here. And I can either run it when I want to, or I can have CS run it for me. You've probably been used to seeing the ability to do weekly and monthly. I've had a lot of people ask, hey, this is a very competitive field. Can you get us the information quicker? And so as available means the day we upload an article to our database that satisfies one of your alerts, you will get an email that day. So great way to stay on top of things. And as I said, this is a great way to stay on top of other people citing articles of interest to us. All right, so let's go back to the main search here. And now I'm actually going to do a more classic search here. Let's say I have a certain topic of interest to me. And in this case, I'm looking at discoidin domain receptor inhibition as an antifibrotic. So a couple things to notice. First of all, we have the auto suggest here. This is kind of going to the database thesaurus, and for the search terms you've got in here, we have information on different topics here, and it's also a good way if you're typing. Keep an eye on that, because it may be finishing the thought for you or suggesting a query for you before you even finish typing. So another way to save time. And so let's just go ahead and I'm going to launch that search. I was pointing you out before that these are going to be sorted by default by relevance. So what exactly does that mean? So we have an algorithm that takes all your search terms, and it's looking for each individual term and its presence in a title, in an abstract, or in the concepts associated with the article. All our articles at CS are human curated, which means a degreed scientist that's studied in the field of the publication will read it, and the concepts they will associate with it are like, what are the key topics to this paper? So if I click on this title here, I can then dig down, see the whole abstract and the concepts here. Fairly new as well is if the author has associated keywords with this, we will also associate the keywords with the records, and those will also be searched by the terms in your search query. So, and then here are those concepts I talked about. So they associated 10 topics here with this paper. And why do we go to this effort? Well, you're out there trying to find all the relevant information on a given field of interest for yourself. And if you've done a good job of creating your search terms and those appear in abstracts or titles, then it will work very successfully. But many times, key aspects of the paper, information involved in the paper, may not be captured in the abstract. So that's why we feel it's very important to have our human curators associate these concepts. So they're things you may be able to find, you may not have been able to find if they did not do that. So, and something else specific about this article, is it has been indexed not only by CAS, but by Medline as well. And you won't have multiple answers. We'll merge them into one. But along with it, we will bring the what's called mesh headings from Medline, where they are also associating what are the key concepts to that. And on occasion, there are additional supplementary concepts that will be added before this application is put together and put online. So going through many efforts here to make sure all relevant information, all relevant topics are captured. Okay, so back to the main search page and maybe talk a little bit exactly how this is working. So as I said, it's looking for all these terms and their presence in the abstract title or concepts or the keywords. And it's kind of a glorified a Boolean search where it's looking for discoid or domain or receptor or inhibition or antifibrotic. There is some smarts to it. It will look for things together. It will look, if you have a prepositional phrase, it will denote it as a phrase. So it does have the ability to, like I say, be a smart search. But that's in the end what it's looking for is connecting these by ORs. So when they're found, they've highlighted in blue, and then there's a scoring algorithm that gives it certain points for its appearance in several places. And so even though I've got 22,000, over 22,000 answers here, even though I haven't done a single bit of filtering, in all likelihood on this first page are probably some pretty relevant answers, articles that are going to be of interest to me. And we put that all in place for the expressed reason that you're going to be getting back larger answer sets because there are no limits. And you'll have the ability to do plenty of filtering, but this is just another way to speed things up for you and get you to the most relevant things as quickly as possible. All right, so, but I did mention briefly that the search bar is Boolean capable. So operators and, or, and not can be used here. And these often can help us, if we understand how to use the Boolean operators, refine down our answer set to exactly those things I want. So I told you that these were linked by ORs. So if I want to make sure that multiple concepts all appear in all the references I'm seeing down here, I can use the operator and I might even recommend, we've always said you can use common language, but you'll see in a couple places here, like an as is highlighted and stuff like that. So since it is Boolean capable now, it's going to think that anything you put in here is going to be important. And so we'll search for it as such. And so in this case, what I'm actually going to do is I'm going to put in a couple ands. So I get just good in domain receptor and inhibition and antifibrotic in all my answers here. So I start out with 22,000 answers. And this should refine it down to a much smaller, more focused answer set. So yeah, now I've gone all the way down to 470 answers. If you want to make sure you're maybe being more comprehensive, it's a good idea to put in certain synonyms that appear maybe fairly often. And with compounds that inhibit other compounds, a lot of times they also use the word modulate. So anytime I'm wanting to put in a synonym there, I typically put in the parentheses to indicate it's one or the other. So if I go ahead and search that, now I brought back some more answers because I'm now including things that also have the term modulate in there. So, and if I want to take it one step even further, you can use wildcards in the search bar. So let's just say in a situation where I want to make sure that I've got the right word in inhibition, because it could be inhibit, it could be inhibitor, it could be inhibiting, it could be inhibition. What you can do is you can put an asterisk after the key root here, and then we'll bring back all the potential suffixes of that. So I'm going to do the same thing with modulate here. And once again, just covering my bases. Maybe I'd like the answers I have here fine. Maybe I'm thinking should be getting some more answers. So this is a way that I can then go out and make sure that I'm covering all my bases and not leaving anything to chance out there. So this will then go back and pull back a few more references. So, now I'm feeling pretty good about the story and I can start moving forward. So that was just me kind of describing the ways you can use Boolean operators to refine your reference search query. Now, additionally, I have all these filters over on the left-hand side, and these aren't necessarily new. So a lot of these filters were around in SciFinder Classic, but you had to initiate them. You'd say, I want to find things that are, biological study. I want to find things that are patent. Here, without me doing a single thing, I know in this answer set of 6,600, I've got over 1,900 patents. I've got over 900 biological study um, publications. So kind of very nice thing to see up front. And I think it's also impressive. Some people can be surprised by the number of different document types that we cover here. Um, all the way down to even dissertations, which may be relevant to some of you working toward your PhD. Moving on down with the filters, publication year, kind of a nice feature here that I can, this is kind of a free form here. If I want to look at things just in the last 5 years or so, I can do that. Or I can say, hey, back when I was in grad school, I remember this publication came out. Yes, it was that long ago for me. So this is a way for me to take that answer set down to 81. So it's almost getting down to a point where I might be able to kind of sift through them, so to speak. But make use of that to, once again, get down to just those answers that are most relevant to you. Quickly, if you have your institution has certain digital rights and they're associated with the account, and let's say that has been done, when I click digital, I know that all the answers I will see over here, I will be able to get that publication, open it up and read it directly because we have electronic rights to those articles. So if that's something that hasn't been done by your institution, that's something that Lauren can help in making sure that happens. All right. Author search, once again, you've seen this before, sorting from most cited to least cited author, but in this case, there are a couple of additional features here. So if I want to search by last name, I can go to that letter in the alphabet and then just be looking at those names. But let's say what I do 95% of the time, I know this will be a huge answer set, but I can search, and then we've kind of touched this topic already when we look for the publications of Professor Sulikowski. It's just a way that you can get to what you want as quickly as possible. So, and oftentimes you'll see in this some of those situations where you'll have the first name and initial, or just the two initials, or things like that. So once again, if you're searching for a certain author, I want to make sure you're including all of their work. I recommend doing the actual search to make sure you pull back all the relevant spellings of the name. Similar capability exists under organization. This is a really great competitive intelligence tool if you want to see who else is out there working on this, and potentially a competitor, or could be a collaborator at some point. You never know. You're able to set things up with them. But all the different capabilities I showed you in the author are present here. If I want to look for the organization by their name alphanumerically, or if I want to enter it in myself, I can do that. Also can sort through your answers by publication name. Let's say you were looking for ACS medicinal chemistry letter publication or something like that. You can go ahead and sort by that and get to exactly the article that you're looking for. I showed you where the concepts were. You have the ability to refine your answer set down by that. And in my case, collagens was something of interest to me. But if I want to make sure I'm getting all the different possibilities associated with collagens, I would once again recommend that you go this route. And this will pull back all the different possibilities that include collagen as a concept in the paper. So my situation, I'm just going to go ahead and I'm going to select those all. Find down my answer set that way. Okay, so marching forward here, it's going down. And what else have we got down here further? So kind of want to highlight a couple of things here. We have some capabilities to allow you to look up formulation information. It looks like at Vanderbilt you have several drug development programs going on there. Once you've gotten through the discovery and optimization, you'll start launching into clinical and hopefully IND somewhere down the road. And then formulations become a very important factor. You've got to be able to throw them together with the appropriate excipients and what have you, so that they are stable and soluble and delivered to the locus of action. And where can I find information on that? So a couple of different things here. First of all, we have a standalone product called Formulas. If once again formulations are something of interest to researchers at Vanderbilt, please talk to Lauren and we can set up a separate presentation on that, because it does need its own time, because it's kind of a whole other database. It mimics this database a lot, but like I say, very specific to the uses for that. In SciFinder-n, I also have the ability to sort for a specific purpose. And since I start out this way, let's say I want to look up antifibrotic agents. So all these articles that I've now pulled back will have information on formulations for antifibrotic. So I can kind of page through them here. And if I click on the title of any one of these, I can scan down and get to formulations information. And now it's going to give me kind of a little abstract of the formulation here, and see how many are in this one. So there's quite a few associated with this. And what I can do in this little abstract form is I can kind of click on here and see all the different amounts they used in putting this together. These are all the different components used. If I want to find out more information about that, and I have rights to formulas, I can click on this, and then it will give me a full view of the full formulation, usually involving process information for how it was actually put together, and activity information into, they tested it and how did it actually work once it was used clinically. So just to point that information out there, once again, if that's of interest to you, we can certainly arrange to do something special on that. Sorry. All right. And one last thing I wanted to show here was searching within results. This is just an ability to do a free text search. Okay, so let's say that I want to look within this answer set specifically at drug targets. And I launch a search there. It can now, we'll go in and look for that, those words, like I said, in the title, the abstract, or the concepts, and we'll bring all those back, and then it will highlight them as well. So all these have something with respect to drug targets, and just like I say, multiple ways for you to refine down your search. All right, so let's say I've gotten to this point and I'm pretty happy with my search. Matter of fact, I might want to save this and run this on occasion. What are my ways to save this search? Well, you have three possibilities here. First of all, you can download it. We have a number of ways to download it, a number of different formats depending on what's relevant in your specific situation. A lot of people like Excel because they can have everything in columns and it's searchable and sortable, that type of thing. Maybe you're putting a grant together, so citation format may be best for you. Anyway, all these different options do exist, and depending on what type file type you select here, You can either select just the result summary, or you can do the details. If you want full details for your whole answer set, you do have to refine it down to 100 answers or less. But even if you don't, it will bring the details back for your first 100, so your top 100 references. For everything, you're going to get the task history and abstract, and then other information as you see fit. So that's the first thing I can do is I can download it and save it on my desktop. From there I can email it on to other lab mates or my supervisor, what have you. The second thing I can do is I can email it. So all I need to do is now put in email addresses, send it off. If you receive an email, you'll have there will be a hyperlink in there, and once you click on that hyperlink, I'll be right here. So at that point, then it's basically my search. I can say, yeah, oh, actually, I'm just interested in the patents, or I don't want to filter down by college in here. I want to take a different approach. So once you play with it a bit, maybe you make a kind of an interesting discovery, and you can send it back to whoever sent it to you and say, hey, thanks for sending me this. Hey, I played with it a little bit, and look who the big player in this area is. So very good collaborative research tool. And then the last thing that I can do that those of you who've played with SciFinder Classic before are familiar with is I can save the search. Give it a name. We already talked about the ability to have CS run it periodically for you if that is what you so desire. While we're on this topic, we have now introduced new capabilities in combining and using Boolean operations on saved answer sets. So here's where I get into the saved answers. And as Lauren said, you still have SciFinder Classic, but if at some point you decide to kind of migrate everything over to SciFinder-n, which we hope you do eventually, if I click migrate here, all my keep me posted will come over and become alerts in SciFinder-n. So I only need to click that button. The other feature I want to show here is the combine. And the combine function, if I have a reference set that I want to look at or manipulate, I can take two or more and I can add them together. I can look for an intersection. So this would be the or, this would be the and this would be the not. So if I ran something 3 months ago and I ran again, I can see just what's new. So all those different capabilities that you have with your saved answer sets. All right. Take a breath here and see if there's anything of note in the chat, Lauren, that needs to be discussed further.
Hey, Gary. No, I don't see any questions in the chat just yet, but I will encourage you to, if maybe it's just my audio, but you sort of undelay and then sometimes it sounds really low. It might just be the way you're speaking, but just to hold the microphone a little closer to your voice. I think otherwise it's been audible. It's just the volume seems to change a little bit.
Any better there?
Sounds good. Yeah, clear.
All right. Yeah, thanks for the feedback. All right. And the last thing I want to show you before I leave the reference search page is you have the ability to do a combined reference structure search. So for this search query I've got here, let's say there's a certain structure that I'd be interested to see if it exists in any of the answers in this answer set. I'm doing some research. I've got a scaffold or a pharmacophore, and I'd like to see if that appears in any of these searches. So what I'm going to do, I could bring in a CS registry number, a smile string, or an inchy string. I'm going to bring in a CS registry number, and it's going to bring back this core scaffold. And in this specific situation, I want to see if this is a structure or a substructure of a structure in any of the articles that I have in my answer set. So I can upload that to the search bar and run this search. So it's going to do that search, and it's going to find that there were two references that had that as a structure or a substructure. So if I want to see the structures that hit on that, I can click on the title and then go down to the substances. And so this has 105 substances in it, but it's brought to the top of the list those that satisfy my query. So the in blue is the structure that I input. So it's a substructure of these larger structures. So that's interest to me, interested to see the different analogs they made, and maybe I can get into the paper and see what effect those had, but good to know if I'm working in this area, what type of analogs they've made. Now, this is in patent pack, and if I'm interested in one of these structures, all I need to do is click on the purple patent pack here, and not only will it open up the patent, it will bring me to the exact page in the patent where that compound exists. So here I am brought to this page, which is going to give me all the characterization data, and it's going to tell me that this was synthesized by the procedure of example one. So all I need to do is go up to example one, and then I'll have a procedure for that. So rather than me paging through this 156-page patent and trying to find this, in the course of a click in a couple of seconds, I've got exactly to where I need to be. One other feature, this is what I came into this paper for, but I came across another compound like, oh, I didn't know that was in this. And so I can now click on that and get a file menu. And I may want to research this further. I may want to look at the references associated with this. I may want to look at the reactions associated with this. By clicking these, I can open up another tab. You can see I've got multiple tabs open. That's something you couldn't do in SciFinder Classic. That is something I can do on the side. And then once I'm done with that, I can close it, and it's going to bring me right back to where I was. So that's patent pack. And actually, since I have this tool open, for a number of patents, you will have the viewer capability, which says all the compounds that are in this have been brought out of the patent, assigned a structure associated with the CS registry number, and a hyperlink to the page here is provided. This can be operated while I'm on my computer. If I would like to have something I could download, we also have something called the PDF Plus, and that will take all that information that was in that scrollable window and it to the end of the patent. So large patent, sometimes it'll take a little while for that to happen. So all I need to do now is go to the table at the end of the patent, find my structure, go across, find the page number and the identifier, and then I can go up into the patent. And all I have to do is look for, whatever number I was looking for. Make sure it gets you to the right place. All right. So yeah, figured while I was here, I might as well get on that. All right. So now let's go and look at reactions. A couple of new capabilities here. And I'm actually going to go into my history to pull up a reaction I've already saved, so I don't have to draw it out again. And this is it. So not a lot of time left, so I won't go through how I drew all this up, but a lot of you have been on SciFinder Classic, and it's highly similar to that. We have the ability, specifically, I highlighted the ability here to both create R groups. I can create up to 20, composed of anything in the periodic table, shortcuts we've created, or variables that we've created. For example, X refers to any halogen. And in this case, I plop that down there, and then I use the variable attachment tool to say, I'd like to look for the presence of these functional groups in either of these positions, both of the starting material and of the product. So let's go ahead and launch this search and see what we get. All right, so it's going to be binned by as drawn hits and substructure hits. So as drawn just means it's a direct answer for the query that I put in, because hydrogen was one of the members of my R group, so that makes sense. And then I also had any alkyl group for this R2. So this was a as drawn answer for my query. We found 3 examples of these in our database, so we grouped them all, these 3 reactions together into a scheme. And that's different than SciFinder Classic. Those of you who like to do it by document, that exists, but we have this additional capability because now, given that fact, I can look at the conditions side by side here and kind of compare them. I see these guys use cobalt, these guys use rhodium, and this group used palladium. So then they're sorted from highest yielding to lowest yielding, and we do associate experimental protocols with certain articles. And this is an example of our methods now synthesis. As Lauren pointed out, you now have unlimited use of methods now synthesis as you do a patent pack. And these are just created by our human curators, where they take the information in a procedure, they parse it out into this nice tabular format. Everything's hyperlinked. If I want to learn more about specific compound, maybe look at pricing or suppliers, I can do that. And then I have this nice recipe style format with times, temperatures, amounts, and workup conditions, all included. And then lastly, all the characterization data that the author provided will be right here, so I can compare and contrast once I isolate my material. Right. Lots of filters over here on the left-hand side to help you out even further. If I want to look at using a specific reagent, a specific catalyst, if I want to look at just those that had discussed the stereoselectivity, I can declare that there. So all these filters to help you out. And there's one additional filter over here I want to highlight by getting into the substructure tab. So here's cases where if I didn't explicitly draw out all the valences for a given atom here, it can be substituted in a number of different ways. So in this case, an ester was formed. Here's a methoxy group, so on and so forth. And I bring this up because I want to point out this is a very good way to look up for the presence of a functional group of interest to you. So let's say I'm interested in this transformation. I'm going to use it in my synthesis. But in my case, I have a functional group that I'm a little worried about. I see acids, I see metals, I see heating. Not quite sure that it's going to be stable to the conditions I'm seeing. So all I need to do now is open up all the non-participating functional groups, and I'm happy to see that aldehyde is here among them. So I can apply that. It's going to bring back that one answer. And here you can see aldehyde exists in a remote portion of the molecule in the starting material and in the product. Happy to see I got a 93% yield, and I even have an experimental protocol associated with it. So rather than me spending lots of time looking at a bunch of different potential conditions, this can helpfully get me to the one that's most relevant, save me time, and open up my day to do other things. All right, so now we're going to barrel on into substances. And in this case, let's say I have a specific substance that I'm interested in. I want to find out more information about it. I'm going to change the substances here, paste this in. I'm going to take out what I was just working on, and I'm going to search for that. And so it brings up this window here that gives me the references, reactions, and suppliers associated with this compound or database. Briefly want to show some of the information that's behind the CS registry number. Here, there's a bunch of different physical properties associated with this compound. Also, if it's ever gone under another name, we'll capture that here because you may come across a certain publication and say, oh, I thought that was my nintedanib. Sorry if I mispronounced that. But you can see, indeed, it is exactly the same compound. If there are experimental properties that have been published, we'll put those here and give you a hyperlink so you can go see them. If you want to pull up a spectra, a proton, or a mass spectra that exists out there, we provide access to that. And if certain articles or compounds don't have anything published on them, we do use AC Lab software to create certain properties, predicted properties for these, Lipinski, polar surface area, things like that. And then also proton C13 NMRs are predicted using the AC Lab software. If we find this compound is associated with a publication that is looking at a specific bioactivity, we'll assemble all those articles and put them into a hyperlink like we've done here. In the same manner, if it is actually interact with any specific target, we'll do the same function here. So just want to point these things out. Some people haven't seen that before, don't know they're there. So I always like to point that out. And want to then put this into the query or the draw tool and to point out a couple of things. Notice that you now can draw with deuterium and tritium here. So if you're ever labeling compounds, and oftentimes when things get into clinical trials, you need to look at metabolism and things like that. And so labeling becomes important. So just want to point that out. But let's just say I want to see all the different compounds associated with this. I can upload this to the search bar and do a search really quickly. It's going to bring things back as drawn, which will be the compound itself, stereoisomers, labeled compounds, radioisotopes associated with a compound. All will be captured here under the as drawn. Substructure, we've talked about this already in the reaction browser. And then similarities, just using a Tanimoto similarity algorithm, you can choose to see compounds that are with a certain radius of a given compound. This is a good way potentially to scaffold hop. It's going to look for other compounds that are very similar. And if you're looking for some white space or something like that, this tool sometimes can be valuable to use for that. All right. I don't know what type of drawing tool you use, but if you do have ChemDraw and it is version 18.2 or newer, if you have a existing document in ChemDraw, you can go to where that document is and open it up. And then if you highlight that structure, you can then go straight to a reaction search. You see these icons light up over here. The farthest one on the right is SciFinder-n. When I click on that, even if I don't have SciFinder open, it's going to upload it to SciFinder and do a substance reaction reference or supplier search for me, whichever I want to do. Just so you know, if you don't have 18.2 or newer, you can go the normal route of copy as, smiles, or an inchy string, and then I can upload that into the CA's draw tool very easily. So that is the different things in substances. Then I did want to spend a little bit of time here with the retrosynthesis tool. So also in the area of searching here, let's say I have a compound that I'm interested in. And I can bring it up. If I click on the structure, I'll get a flat window, and you'll see here, create a retrosynthesis plan. So if I click on that, it's going to go and look for a way to perform a retrosynthesis of this. This compound, which was published by Vanderbilt in the ACS Medicinal Chemistry Letter Journal recently, hasn't been indexed yet. So it doesn't find the retrosynthesis, but this is just to point out that the retrosynthesis tool even works for compounds that it doesn't have a published experimental for. It will go ahead and it will look for a predicted approach to that. I've done this for you. Synthesis and the what I want is here. So you'll see that there are green dotted lines using this retrosynthetic scheme. And what this is telling you is that we didn't find the exact combination of D plus E to give B, but we see the transformation that's being accomplished there. And basically you're linking the carbon of the aldehyde to the nitrogen of the aniline. And we found other ways in similar systems, maybe not the exact same functionality on that. And we'll propose this scheme. So, and so these are actual articles that are in our repository. And since it is a predicted transformation and not, pulling back an exact example of it, it will average all the different examples it finds, so it can give you an idea of how well that chemistry should work. And so it can associate these average yields together with supplier information. So this is the compound we're trying to make, and we're going through a series of disconnections until we get back to reasonably priced commercially available starting materials. And what is reasonably priced is $1,000 per mole or less. The supplier's hyperlink is to all the suppliers that are in our ChemCats database that offer this compound. So if I click on this, it will fly me out to that and shows me all the different suppliers, information about that, the purity, the pricing for most of them, and then very important, whether or not we maintain it in stock. So I've got 87 suppliers to choose from. I can use all these filters over here, so I can say, hey, ships within a week, maintain in stock, and then hopefully it has a US address because I want to get these things really quickly. So that makes searching for suppliers easy, and hopefully gets you to suppliers that aren't going to give you any surprises by things not being available or what have you. So by using this pricing information, we can combine that with the yields to give you an estimated overall yield and an estimated price, in this case, to make 100 grams. Other information we provide for you are the evidence for each of these steps, and then if we find alternative steps. So if I had any questions about this approach, I could look at the evidence associated with it and kind of determine whether or not I think it's viable or not. Conversely, if maybe I wasn't super happy with the approach that they were taking, it's going to bring back all the different alternative steps that could be used to make this compound. So since this one does have a lot of alternatives, sometimes it takes a couple extra seconds for those all to be pulled up. But once you're in there, you can then see all the different potential transformations that we found to make the compound, and then you can select the one that you like. And once you do that, it will then go back and it will recalculate the retrosynthetic scheme to incorporate this transformation, and it probably will change your yield and your overall price. So, for example, in this case, it's kind of purporting a reductive amination to get to this point. Let's say I feel a little better about making an amide via carboxylic acid and the amine. So we'll then go back and do recalculation. So things got a little more expensive. So I'm going to go ahead and look through these and maybe start tweaking the other steps as well. In this case, once again, it's trying to do a reductive amination. So I'm going to kind of scan through here. And I think it's going to be better availability for me to go through the nitro and then reduce it down. So I'm going to select that possibility. And see my costs now dropped off a whole lot because that compound is much more reasonably priced. So I know we've reached the end of time here, so apologies that I went a little bit over, but you do have, just really quickly, other options to modify the plan. I can have more or less depth. I can use more rules if I want to look at slightly rare chemistry involved in making this compound, and I can also say, hey, rather than the way you disconnected it, I'd rather have this be the first disconnection. So that's one possibility. And additionally, if I've got a certain starting material in-house or intermediate in-house, and I don't want the tool to perform any disconnections of this, I can basically declare a starting material by selecting the bonds like that. So, and then the last thing that you can do as a way of modifying this is we do have a scoring function. So there are a number of things that are involved in calculating our schemes. These are 5 of the characteristics that go in: complexity reduction, which is just how much simpler did it get step to step, smaller, less rings, things like that. Convergence scheme is usually more efficient than linear schemes. I like to have more evidence rather than less evidence. It makes me feel like it's more robust. Yield's pretty straightforward. Atom efficiency. A lot of people like to have all the atoms they use in their synthesis be incorporated in the final product. But sometimes you have multiple functional groups that are reactive and you need to put on protecting groups. So you have the ability to either turn these completely off, low, medium, or high weighting. So once again, thanks for your time and your attention. Sorry, I went a couple minutes over, so I'll stop there.
Hey, thanks for that presentation, Gary. Are you able to hear my audio?
Yes.
Okay, great. Thank you so much. I'm going to share my screen just so everybody has this, just a reminder about additional information that you may need. I'm going to go ahead and stop the recording as well.